Hi everyone, Sam here, streaming procedural generation development in Unreal using my Apparance plugin tool for building procedural systems. Fully interactive, runtime, made for games. I've got a number 5 of fifth stream. I've been putting together or assembling bits of an asset pack that I found that makes for a nice space station interior. This is what we've got so far. Walls made out of several pieces, various choice of windows, wall panels, and then the floor is the thing we looked at last week, and introducing floor patterns because there's a number of different tiles and pieces to use to make the floors. And I guess it's a bit of a deep dive. We're going to go and look at the floors in more depth. Applies to ceilings as well. It's going to be used, just a different asset set. Yeah, so we started last time. Originally we had just a grid of unit tile pieces. It wasn't very interesting. And then last week we expanded on the framework, or started setting up the framework for doing a sort of recursion based interesting subdivision of floor space. And we're going to carry on with that. So that's the plan. I'm just going to noodle away at the floors, make them more interesting. Because at the moment we've got patterns like this, and we saw also we got some put on, see them changing. So yeah, as the seed changes, you get different patterns, and that shows the kind of stuff we're doing at the moment. Largely, it's I think we had taking the space, deciding if there was room to subdivide. If there was, split off a piece of the end, and then recurse into those spaces. I think, and then when it got down to a certain size, it started placing instances, and I think we handled some 2 by somethings, but we'll have a look at that again in a minute and remind ourselves where we got to with that. Okay, these can all this is our little test suite. We've got these two are floors and these two are ceilings, and the difference between them, it's the same procedural logic, but they are pointed at different asset kits. See if I toggle this, you can switches between thing with the ceiling and floor. Floor tends to be much flatter. The ceiling has got some protruding bits and greebles and things. We seem to have some anomalies with these pieces, but we'll look at those later on. Okay, so if I open up our procedure editor, so and start digging in. Right, so the parameters we've got in are the bounds, which is the space we're filling, whether it's a ceiling or not, which switches asset set, and a seed value, which propagates down and drives some decision making. Hey Ed, how you doing? Been a while since I saw you streaming. Now it's your turn to watch me. Feel free to ask questions or distract me with interesting procedural pieces. Yes, so that's where we're at, and I'm going to start digging in. I can't remember where we left it in terms of what we were going to do next. So let's just review what we've got, and then I will pick on something as we go down through. So this is the top level floor fill procedure. It's the one that's used in this room to do the floor and ceiling. You can see in here that the ceiling is being done as well. And then for these ones, so this is our entry point, and down within these, we actually find we recurse into these. Hey, Laura. Welcome to the stream, procedural people. Yeah, so this top level has a couple of decisions made in it. We calculate how many actual tiles there are across the floor, because that's kind of drives some of the decision making. In this case, we've got if either of the axes of the width or the height is 4 tiles, then we've got a special procedure for doing things with that space. And up here we've got a decision about whether if it's bigger than a certain size, like 3 or above in either axes. Oh no, in both axes, we do the side subdivision where we chop off a piece and then recurse. And then the default fallback is just a grid of unit tiles, because that'll fill any space, whatever's left. Always a sensible fallback, and then we'll never have a problem of missing pieces. So let's just have a look at these two. So subdivide 4s. Again, we are dividing. We've got another decision made here, and look. Okay, we're normalizing the orientation, so it's always x is 4, I think, in this case. Yeah, and then height we look at. If it's 4 or less, we've got a procedure for fill a small space with 4 tiles, and if it's bigger than that, we chop off the sides, use that same procedure, and then the center piece we go back to our main filler procedure, and that can make more decisions about exactly what happens within that space. Place 4s, what does that do? Again, more decisions. We're using the floor grid filler procedure, which is you can give it the assets you want, and it'll do a 2D grid of all that space. The first decision is the height even? And if it is, we can use if it's even, we can use either 4x2s or 4x1s, and it chooses those with a 50-50 probability. But if it's odd, then we have to use 4x1s. It's just a bit of logic there to fill out that last bit of space when we're down to a small space. And the filler here is back to our top one, recursing here. And then our side split here, if there's 3 or more in both axes, we can again shrink by 1 unit. And okay, because we know it's 3 or more in both axes, we can do it in either axis. And that's 50-50 choice of which axis. And then the 3 spaces we just fill with different things, although the center has a different seed to the outside, so that means the 2 outside slices will use the same seed and generate the same content, which is part of keeping the idea of keeping symmetry on this floor area. Okay, brings us back to here. The grid we've seen before, that's really just a series of rows, and each row is a series of pieces. Just a filler, a floor filler, if you will. Oh, right, what next? So many choices. When I did the procedural ornamental gardens, we ended up with quite a lot of different sorts of logic that we switched in, including different like not right angle orientations. So you could have like triangular pieces, and then you would end up with a sort of diamond square, and then you could recurse into that. And plus, it also generated the ground geometry and for pools and levels and things, and textured it all, as well as placing all the foliage and things like that. So that got quite involved, and we can do a similar thing here. Question is, what next? So there's a couple of things I was going to look at. One is the border. Go back to in a minute. We dig into go back to the parts list just to have a look, get a little bit of inspiration about what we're going to do. So this is the asset kit we're working with. we've used these wall pieces. These are the floor pieces, and then these are the ceiling pieces. So we've got some of these hooked up, ready to use in the resource list, but some of them we still need to do. We've looked at the 4x somethings, and there's a 2x2 I think is hooked up, and then there is the 1x1s. I don't think we've hooked up the 2x1s yet. So we could look at what to do with a space that's 2 width, or look at that in a bit. But these pieces here are the interesting ones. I was going to at the these border pieces. So there's a corner piece, and then there's a couple of choices for straight sections. Now what we could do, so we can incorporate these nice areas into mark area subsections of the floor ceiling, I guess. We could build a procedure to handle that. I think I might do that next. So we're going to make sure these assets are available, and they are slightly special, I guess. So we have their own places in here. This is the resource list where we basically look up or map from within the procedure by scripter into the actual assets that Unreal will place. Floor and ceiling. Not this. I think the border probably we'll treat it as universal because it's custom. I might have own section. Right, folder here called border corner, which is on here is these aren't particularly cool. Put it down here. Right, not easy to see on here, but somewhere here is, I think it's that one. Open it and see. Yeah, that's our corner piece. Here. Variant in case we have more. And then we also want. Now there's a single piece, single length edge and a double length edge. So I'm going to do edge 1. Could be the and I think this one. Yep. We'll worry about the alignment of everything a bit. And then there's a 2 somewhere. Yeah, that one. That as well. That needs to be double check that. Yeah, our 2 unit piece. So let's start with the corners. Going to be our descriptor. I'll take that and come back to it in a minute. We have things down. Okay, we good. We're good. Let's create a procedure for this. So it's going to be another one of these subdivide, kind of a way of dividing the floor into more bits. So we'll call it border. So we've got a 9 slice procedure here we can use for this, because that's going to allow us to chop 1 unit off around the edge. The logic of whether we can do this, and there's room, will come outside. We'll come back to that in a minute. This is basically all of the pieces we need to be filling in for our floor. And then the center, we'll be left with a center, which we can then recurse and do the filler stuff again. In fact, I'll put the filler in now. no, what I'm going to do is I'll just put a placeholder in so it's clearer what's going on. I will show the frame, the outer frame. This is a good way of, often a good way of working is test it in isolation with some debug geometry or visuals just to make sure you know exactly what's going on where. So we'll show the outer frame. Let's get that working first. There's going to be loads of pieces, so I'm just going to bung a big old merge in. We can put in a custom for this. So we've got on floor border. Invite. So that's our frame. And I was going to do a just for the center space. I'm just going to fill with a box. It's full height. I don't want that to kind of be in the way, so I might just fit it. Right, so in the Z, so half a unit high in Z maybe, or let's do 0.1. There you go. That's just the bottom kind of floor. We'll give it a bit of color. Yeah. So this shows us our this shows us our outer frame. We've chopped a unit off all the way around, and then there's the recursion can carry on in the middle. So now we need to start putting some of our pieces in. As I've done with most of the other procedures, I've got each piece, rather than doing the placement in here, I've wrapped it in a procedure in case we need to do some other funky logic in there. I'll do that the same. So we want floor. Let's add a board. So I've got a little procedure for that. Now, I think because we're not distinguishing between floor and ceiling for the border, I think we'll just directly refer to the assets, which means I can solve. Hang on, I'm going to need to use that. Did I keep the descriptor? I did. So that's the corners. We'll assume there might be more than one. I did a no. Do that. Add another utility for assets. That is going, just building little utilities here. Bear with me. So we need to know how many we've got. We need to choose one in the range 0 to this size 1. The list is indexed. Get the index. We will have feed in is a assets, and there's a seed value that we will break into the pieces you get. So that resolve, like here, gives you a list of little asset structures for all the different variants it finds, and that list will grow as if your artist maybe put in variants for your meshes, and then the procedure can just deal with that. And that's a list of structures that are, well, structures are represented as lists as well. So it's another list of the asset ID and the bounds which we can break out. So if we get, not in here, sorry, no, utility, we're going to get the ID, which is at 0. So just making a note here, asset ID, and then the bounds is 1. Oh, no, I've done the same thing twice. That's not an ID. I mean, that one. So yeah, get an integer. So we get an ID and a bounds. We get a new seed. If we want us to carry on, let's rename these to make them sensible. So that should be enough. We won't do any error checking. The assumption is there will be an asset, and a check would need to have been done elsewhere for that to make sense. Right. That asset, we can then place the chosen asset somewhere, and that'll do for the minute. For the corner, I think we'll do some resizing in a minute, but like we did before for some of these pieces, because the thickness we want to match the original asset, not the frame we've passed in, but we'll try that, see how it goes. So we have floor, piece, corner. So let's start at the bottom left corner. Southwest, and we have a piece. Oh, look at that! It already aligns. So the height, that's the right corner piece for our border. And given that this slice utility procedure reorients the pieces for each of the corners and sides, it should be that we just plug it in and it'll all just work. Let's do that, and then we'll fix the height. Northwest corner for that. Diagnostic stuff out of the way. Might just do a little diagnostic. Yeah, diag stuff out of the way. This is the main bit. Let's put in another for the southeast. And for the northeast. Okay, we've got corners. I'm going to fix the height thing, which I mentioned before. So we've got the bounds information, so we can extract the Z, which is vertical in land, and use that to force this frame to be that height. So now that's the original asset height. We know these assets are on a unit grid, so the 1 by 1 we've chopped off from the surround is correct. So that's effectively the same as the original asset. So we have a corner piece for our border. Now the next question is, what do we do with these straight pieces? Because we do have a choice between the single and the double pieces. We're going to know how long this is and how we're going to divide it up. But I'd quite like it to be, I mean, it can be random, make it interesting, but I'd quite like it to be symmetrical. So we need to work out how to fill that space and have the decisions be same both ways. Different ways of doing that. I quite like using a technique where you generate a large random number and you just use the bits along it, but you mirror the index. We can do that, or we can fill the space and split it up and have the same procedure, one reversed, and have it randomized with the same seed. Maybe that's a better way of doing it. Another consideration is that as we are filling that space, choosing whether to use 2s or 1s, if it's an odd number of tiles, there will need to be a center tile, single center tile, for it to be symmetrical. So we needed somewhere to put that logic, and then the filler logic for the two sides. We'll do that. So we're going to have a procedure for this edge, so like border edge, and within that we'll decide whether we need a single piece in the middle, and then we'll have another procedure for the run. That's probably the way to go. And then we can use the same seed all the way around, and that'll match. Or we could do the same seed on 2 sides and not the other 2 sides. We can play with that in a minute. But let's start by putting in the. Let's start by building a fill that will just fill a space with random. Start there. All right, so we're going to be looking at this edge here. How are we doing? Good. Any more questions, anyone? I am going to create a procedure for that. Where are we? Floor, piece, corner. So we're going to need all the procedures for placing single or double. Well, we won't do it like that. We'll come to that in a minute. We're going to assume that it's either single or double length pieces. And let us. I mean, this might be something really useful, so I might just use it as a. What would we call it? I mean, it's part of the border. Subdivide border. Border edge. Let's call it that. I mean, if it's useful somewhere else, we can just reuse it. Oh. Sort of background stream watching there, Ed. Nice one. Right. Single tile width border. Cool. That's what we want to achieve. So what we're going to do is, so let's have it so that so we build along the x-axis. Assume the y is 1. What we're going to do is chop. We're going to right. So let's have a look at the space we're filling. So we've given a bounds. We need to make some decisions about what we're doing based on how much space there is. If there's only 1 unit, roughly, use the tile count. That's probably better. We've already got this utility that works out how many tiles we've got. We'll ignore the height. We're building in the X. In fact, I'll put build X just to make a note so we know that. So this width is the distance, the number of tiles we've got to fill. So if it's 1, we have to use the 1s. If it's 2, we can use either. Very similar to the decision we had before on, elsewhere. And if it's more than, well, actually what we can do, 1 we'll use 1. If it's 2, we'll use 2. And if it's more than 2, we will choose one or the other and chop that off and recurse the rest. Let's do that. So we need to do a comparison. So we've got integer comparison here. If it's a 1, we're going to do a particular thing here, which is fairly straightforward. If it's 2, we're going to do something else. Oh, actually, I wonder if it's better to do the switch on the. Of course, we'll do it this way. So previously, when we were doing this with the, I think it's the 2 by somethings. These utilities here somewhere. We do it. These 4s, I think, in there. We switched. I'll find it. Yes, so here the decision making is selecting which assets, whereas which we could do, or you can switch what geometry you're going to select, or what content you're going to select, and then have all of the logic for each one in that. And I mean, this has a little more elegance to it, so I might do that. Decisions. Yeah. Sorry, distracted by random bots. Okay, let's make a decision on this edge. Do I want to do it like this, or do I want to do it the way? So in the case of if it's not either of these, i.e. this false input here, I'm going to need to do some recursion into the sub-procedures, which will produce this geometry anyway. So I can't use that the asset selection as how we're going to do it. So I will do it like this. But what I am going to do is the assets we need. Nope, not that one. Wait, I just right. I'm going to get a resource, choose one, and then place it in that space. Wonder if it would be better to. We've got piece corner. I might do. I'm going to do that. I'm going to extract this to be. Oops. To placing edge pieces. Edge piece of length. So very similar to this. In fact, I'm going to copy all of that. Largely going to be the same. I have seed. Oops, sorry, seed where it's going and the output. That, and that. Instead of corner, it's edge. Except it's not called edge. It's called edge 1 or edge 2. So we need to be able to. Sorry. We need to be able to switch this according to whether we want 1s or 2s, which I would going to do with a 1 or 2. Kind of hard coded, but that's not the end of the world. And in here we can do text operations. So I'm just going to join this string here, join that to it. I'll do for now. I guess we could have a number, but I don't think we may want like 4s or something in here, so we could add that as a number. But for now, it's just a flag which can be on or off. So pounds. We are going to. Yeah, because the frame we pass in, we'll know what we're asking for anyway. So let's just go with that. Right, that means we can place piece edge. So for this case, where we know it's 1 long, we just want that. And in the case where we know it's 2 long, around. So if it is 1, we use the true channel. So yeah, we want this piece, and for here we want the 2s, and see where how we would use that edge. So let's look on our south edge here. We'll hook that up. What do we get? Great. What has it done there? Okay, it has filled the whole space with a edge piece sideways. Good start. Right, it looks like the orientation geared for the Y direction. I think we should probably all the assets along around. Let's test that theory by putting a Z utility frame. Okay, so we've got X that way, Y that way. Yes, we should probably reorient that. Wrong way. Better, so we can build along the X and Y is that way. Go back to any difference. Interesting. Oh, because I haven't hooked up yet. Yeah. And now, because we've reoriented. Okay. Kind of works, but that's not supposed to be that long. So what we actually want. Why are we? Oh, wait a minute. That was right. X. We're looking at the X. Ah, this piece is too long. This space. So it will be going. It will be failing both these tests and end up here, which doesn't place anything. We can probably show that by putting frame in here. So it's falling back to that. But that makes sense because this is a whole. What I need to do now. Right, so the logic we were talking about before is if it's bigger than 2, we can chop off 1 or 2, place a piece, and then recurse. And that's what we're going to do. So let us. What's the best way of doing that? No, let's just do a bit of logic here. We'll need a seed anyway. So 50% chance of either. You want a 1 or a 2 is the amount we're going to chop off, so we can split. See what we've done. Nope, units. Right, so the first choice it did was split 2 off. Fine. We then can use this procedure. Thus, but we don't want to always place a 2. We want to do, if we've chosen the 2 size piece, we'll place a 2 size piece. If we've chosen the 1 size piece, which is false, we will not be placing a 2, we'll place a 1. Pop that in there. Look at that. Now, in addition to that, we've chopped a piece off, but the remainder we can do all this logic again, so we'll do that next. Spaghetti time with Sam. Thank you, Tom. Neat spaghetti and modular spaghetti and reusable spaghetti. There you go. It's all about managing your spaghetti, and we have the tools to do that. Yeah, I've always maintained that spaghetti is a tooling problem, not necessarily a personal problem or something fundamental with node graphs. So there. Let us do the recursive bit. So we've placed our piece. We want to use this procedure again. And the remainder. Just the seed in a minute. Of course. So I put the reorient in here, which means that if we recurse, it reorients again and everything gets twisted. Do you have sensitive nodes? No. There madness lies. Largely because of the premise that the output of a procedure is fully defined by its inputs and in a deterministic way. And I mean, within a procedure, you could do that, but generally you would probably just have some wires going across the procedure. I'd like to do some things to help you manage wires in larger procedures. But if you have them between procedures, there's a lot of, it's very difficult to track what's going where to where across your procedure hierarchy. And you are better off probably having it visually passed through whatever the sequence is you need to get it from A to B. It's, yeah, that's the kind of logic for that. Globals, yes. So another technique I use for the global stuff, which I don't know if I've done yet in here. No, I don't think I have. If there's like global constants, I would often put them in a procedure, and then I can just instance that procedure in different places. It's not quite the same thing because they're harder to parameterize unless you also bring in, you propagate through some information that those constant globals procedure can use. But then the globals are work quite well for a lot of these cases, where because you can open that procedure up and there's just some values in there with sliders, and when you change those values, everywhere it's used gets affected and everything gets rebuilt. Good for things like colors or just magic numbers you've put in for decisions, that sort of thing. You know, like a probability for deciding something might be something you want to control centrally, and it's used in multiple places. Might be a good example. But if you want to start parameterizing your globals, then that's a bit more tricky. And but there's some techniques that can help with that for passing through high-level control in a relatively simple way, based around the list type, where you use them as a structure of any size of values. Build that in your top level, and that's going to be your control point, and you obviously parameterize it on your object. And then you have a single value you can pass through your system to configure everything, and that's largely the way I would advocate doing that, because it's very much clearer where things are coming from. Yeah. So this reorient being in here is a problem. It can't be done in here actually because we're recursing. I'll label this. Because it keeps getting applied. So what we'll do is we'll move it out, rewire all these to the outside. Take that. There we go. Okay. So we're recursing, but we're always using the same seed, so it's always going to make the same decision, which happens to also be 0, which is what was decided here. So we're always making the same probability decision, and it's always 2, and that's why it's here. And it's recursing until we run out of space, and then it stops. That's our exit condition. So I'm going to bring in. I'm going to generate a different choice each time. So this changes the seed stream each time. Now we can see we've got a bit more variety, and if we hook up that would have just brought it a seed value here. We can fiddle with that. So here we can see the seed value basically randomizing our choice. Now, one of the criteria I wanted here was that this is symmetrical, and this isn't, but this is the first stage in that. What I will do is we'll look at that logic of using 2 pieces or a centerpiece to make it odd. The corner pieces, there aren't any variants, but I am going to we won't hook that up yet. They're just single corners. We do want to put the other edges in. We could do that. going to need to duplicate both of these because it's different source each time. West side and north and east. Again, this utility is reoriented anyway, so it's the same reorientation. We are using the same seed on each one, which we'll come back to in a minute, so that's fine. But this edge, I want to. Would we do it in here? No, I think so. This edge is a generic single edge with randomized pieces. What we probably want to do is add another. Is wrap this effectively. I'm just going to do. Doesn't really warrant a comment, but so I'm going to use this, but I need to make some decisions about how that's used. And again, that's based on the tile count coming in. So if so, this width is the space we're filling, and we need to know if it's odd or even, because then we'll need a centerpiece and switch logic. Let's do that. Now the trick, there's a trick I used last time, was if bit 0 of this width is 0 or clear, then it is even. It means that that's an even number, and if it's even, we will want to do 2 even splits. If we just do it like that, let's do some bit logic. What we're going to do, we're going to need we'll need 2 edge rows regardless of whether there's a centerpiece or not. So what we'll do is we'll just select whether or not. Ooh, what I'll do, I'm going to split. Nope, not the right one. If I use shrink, which we've seen before, that takes a frame and that reduces it down to a particular size centered and gives us the 3 pieces. If I a bit cheeky, but if I split by, so for an even split, I want a center section of size 0, and for an odd split, I want a center section of size 1. Do that. Oh, not proportionate. And yeah, that's correct. So now, should be able to hook up that all together. Max of 3 pieces. See what that does. So now we've got this wrapper where we were using it before. We're going to use the symmetrical one. The general rule. Seed in. We can use the same seed both sides because we want it to match. So we can. Well. Okay, it's not as easy to see on this, so I'm going to make this bigger. Let's go big space. Let's see. So we can see a couple of things going on here. So we've got these 2 pieces at the bottom, and you can see they now are the same, but they're the same way around, so they're not symmetrical. So we can fix that first. First, don't need that anymore. So to do that, to fix that, we're going to reorient one of them. Frame, reorient. This is quite a useful operator. Gets used a lot. And that changes the orientation of the axes in the frame without changing its place in space. Which is effectively, if I just you do 2 steps, it's effectively a 180-degree rotation, but you can see if I do it the other way, it's actually keeping the shape in space. So now we have our symmetry, but because we've got an odd number, we are so an even number is fine. An odd number, we get a gap. So we need to use this centerpiece. If we are odd, I'll conditionally select whether or not we want a piece in the middle. And we need a edge piece here, and it's a single piece, so it's always going to be a 1, and it's odd. There we go. So that is our symmetrical edge piece and the logic that drives it. And try some values. Yeah, all good. Now we should get like 2 because we're assuming we're bigger than a certain size. We'll come back to that. 4. Here we go. 4 is the smallest it'll cope with. Ooh, 3 would 3 work? Would work. 3 work. So it's breaking and going off to infinity. It should be a side to put a 1 in there. Ah, no, the symmetrical logic doesn't adhere to that. The symmetrical logic assumes there's always enough for the side pieces. We've got 2 frames here that have ended up ridiculous size. We should probably fix that in here. I think if this width is 1, that's the only case we need to deal with, really. If this width is 1, we need to place an edge piece. I wonder if there's any simple logic here we could do for that. Yes. 1. I'm going to get a 1 here, so this will work. I think we just need to turn off these 2 if it's turn them on if it's greater than 1. Oops, that float one. Greater than 1. Enable these to that. Turned off. Okay, so it's building. It was building off to infinity and running out of space, and so didn't place the other one. So now we've fixed this one. We're seeing the other side. Do that here. There we go. And now everything finishes properly. So they all have a bit of logic to decide whether they're needed or not. If it's big enough, we have sides, and if it's odd, we have a center. Odd. Okay. Better procedure. Let's make this back up to 25. So we've got some symmetry. These ones are still using the old procedure, so let's fix that now. Out. Should have. Just yeah, and we should have 4 symmetrical edges to our border. Looks good. We can seed and we'll get different. If we wanted to bias the choices here, then we could change the probability of choice. Do we want fewer of these pieces? Twos? Oh no, those are the twos. Anyway, we need some more assets to make it probably much more interesting. That works quite well. The other thing I was going to do is these sideways, we could have, still will be nice and symmetrical, but the opposite sides could have a different seed to the other pair of opposite sides, if that makes sense. I might just do that for fun as well. And we can, I mean, if it's different sized, we're going to get a different pattern anyway. But if it doesn't matter, no, because the corners stay symmetrical. Our logic. I don't know. Let me know what you think. I'm going to leave that for now. What we'll do though is we can now we've got this border done, we can start using it in our floor patterns. So what we would need for that is this center section. Whilst at the moment we're just using debug stuff that off, but we do need to know what that center is, so I'll take that I'll add that as an output. When we get to our logic in here, we can use that. So fours was a special case of like it being 4 wide. We can fill things in. Let's label that as a 4. That there's a little that. This is our default. That, and this one is one of several possible choices of how we subdivide a biggish space. So what we can do is instead of doing, this is saying there's enough room to do some subdivision, so we'll leave that outside of all this. And bottom. I expect we'll have more special cases at the top. But right, this is where we're doing subdividing. So currently we only have this one, which is take the sides off and recurse. Now we've got a new one, which is by border. Take the space and seed. Now again, we need to decide which one we're going to do. So we'll hook them up to here. Do we do border or not? And then that's the decision. Border, borders, but it doesn't go any further. Let us decide then, based on some probability. And this is where decision affects it. So this is where may or may not be this sort of decision of, this is not necessarily an equal decision. It's like it might matter what proportion of each of these sorts of subdivisions you have. So I would say that the border, because it's quite unique and does stand out, I would say that's something you want to have occur less often than just filling it with interesting stuff. So if let's turn this down to say, let's do 20%. So there's a 20% chance that it will decide to do a border and then subdivide each time. So that's our border. Probability. I realize I've brought this center out with recursion, but I could done the recursion inside there. Might not, because it's useful as a utility. We might want to decide to put something else inside it. General ordering type bit of logic. So I will just go straight, add it in here. We'll recurse into ourselves. And going to need a difference. Know whether it's this or not. Seed, because there is here. That. And we need to make it be the border plus the content instead. Okay. Nice. Doesn't align with the ceiling stuff. I think it's not designed to be used on the ceiling, so maybe we would not use it on the ceiling. We haven't got it here. That might just be chance. Let's have a look. There we go. One. So there is a chance that it'll use it. Chance it won't. But it does produce a nice. So what else can we do? So maybe for now we turn it off for ceiling, which we can do with if it's the ceiling, 0 probability, and if it's not the ceiling, it's the floor, we're gonna have. I'll do 25. It's a bit just to give us a bit more. That's one way of modifying the probabilities. Criterion. Yeah, that's good. Border, quite nice. Mixed in with all of the stuff. This one, if I change it to this large one, that should be our floor filler. That. Look at that. Look at that. Borders, pieces, all sorts. None of this 2's logic. That's because it's an odd size. That might need investigating. Let's do. During late in the generation. So it's because a bit above a certain size, it will decide to certain side. It will decide to do the subdivision instead, and it's only the fillers that get used at the end. What? So that's showing up a sort of bias in the logic away from that. Quite nice to have other patches that look like that. So we can have a look at how it's decided. I think it might be to do with the fact that we only chop a small amount off of the side before we recurse. Have a look at that. Change that. Sides. Ah, look, we're always chopping one off. Interesting. Well, we can do better than that. I'm going to find out how many tiles we have. Always. Oh yeah, the axis is chosen randomly. Okay, so if I do this, 0 is x-axis width. This will be number of the tile count in the axis we're going to split. So what we can do, so if we're splitting off that amount for both sides, now we could do that as a. Oh, hello. Thank you. This is a sort of very much the more logic and richer you make the procedural decisions, the more emergent variety you get. I don't know if that's a good term, but yeah, it's, and the fact that also you can just scale up and it will just keep applying it over a larger area and generate interesting patterns is another sort of factor in that. Right, where was I going here? If we decide, so the minimum and maximum we could chop off the side is going to be whatever the width is. The maximum we could chop off is the width -1 divided by 2. We just round down, and the minimum we could chop off is 1. So we could randomize that and then feed that into the amount we're shrinking here. So we want a random value between 1 and value from here. So let's take, if we divide by 2, we could get a 0, nothing left over, which we don't want. So if I take off 1 from this here, 1, that's taking 1. And we've got 2 sides, so if we divide that by 2, if that's our maximum, break. Oh, because we created an input loop dependent on this output. Fine. Right. We now have a value of how much we want to split off, but this is an integer. This is a float. So if we convert those, that is the amount we'll chop off. What does that do? Okay. So we can see more, the larger areas being chopped off. Okay. Sorry. Yeah, so we can see larger areas being chopped off. Let's try different variations. Oh, well, now we're getting a lot more of the 2s. It's deciding to do things with those more often. Getting a lot of repetition over areas, which isn't ideal, but it's probably just. Do you have any thoughts on the difference between variety and variations? Yes, I think variety is. Variations is like choosing from a set of similar assets that have different visual appearance. Variety is more about the richness of the output, I think. Because variety can just be random. You randomly choose, you get infinite variety. That's not particularly useful. That's the whole oatmeal thing. Where variety works properly is where you're driving the logic and decisions to give you richer outputs, richer range of outputs. That's how I would class them. So variations being there are 3 different versions of a 2x2 tile or a 1x1, and that does add to the richness, but it's not as powerful as a concept as variety. There you go. Top of my head, that's my response to that. So something that happens here is if you've decided to do a border, maybe you want to force it not to do a border next time, or similarly, if any of these decisions are made, it maybe doesn't do that decision on the recursion. That's something we could look at. Got quite a bit of space up regular. We do need to look at the smaller tiles and how we use those to fill spaces, so that's going to be something we do. Tricky. We do get some interesting shapes, and maybe these large areas, it makes sense to look like this. The smaller areas are probably a bit more varied. I mean, what have we got in here now? Load of stuff. No, hasn't got any borders. What about here? Hasn't either. What about here? Too small. It's just gone for the simple stuff. Let's see what we get if we Yeah, lots. So more variety than last time. We get borders occasionally. I mean, we've only added borders and improved the side chopping. So there's lots more we can do, especially when we get down to the smaller spaces or the narrower spaces. I think when a space has width 2 at the moment, it just uses the fill. And that's probably why we're getting a lot of this stuff. We have got some 2 by n assets that we can then use within that space. Maybe we could use a similar logic to the edge and have it do the fill with a pattern and a reverse thing to keep the symmetry. Have a look at that. No, philosophical questions are good. It's all part of thinking procedurally, I guess. There's lots of. It's very much a mindset. Very much requires a lot of thought. And this sort of recursion-based rebuilding, if you like, things interesting and added variety. I've used on a number of different projects. One of the earliest ones was a procedural spaceship I built where it was kind of a semi-modular surface that would then populate, and then with different ways of subdividing that surface, and then some of those were like put an extrusion on, but then you can use the same logic for all of the sides of the extrusion, and then keep the seeds symmetrical and all this sort of thing. And that produced some very good results. I'd like to revisit that one day in Unreal, because before it was in my very early test engine, flat polys, and it was all geometry generation, no meshes and stuff. It is fairly symmetrical. I wonder if it could be made more organic by adding some levels of identity to higher quadrant levels. Yeah. So I was thinking about dividing into 4 and doing a crisscross seeding. Hey, we can do that. That's probably quite quick. That might help. Also, yes, the whole 2 sides having the same seed thing. At the moment, they will. I think they kind of artificially come out symmetrical when they are technically not. They're the same way around. So the edge split, the 3 split will need some improvement. But there's no features yet that break the symmetry. So maybe adding it in something that does break the symmetry slightly. So maybe it's a rotational symmetry. Would work. We can try that. That's something I can do quite quickly. So do that. I might leave it running. Tick mode. So at the top here, we made a decision to border or not. So this is border. Let us another decision and switch to feature here, which is going to be called to rotate. Quadrants. Now quadrants kind of needs in theory needs even splits. We could throw caution to the wind and have sometimes it's offset slightly and different. Maybe that might add some quirkiness to it. We can always limit it to just even numbers if we decide that's not going to work. Let's grab this so I can set up the same output. Quadrants, it's just going to be 2. It's going to be split. And both of those are split as well. Split in Y, X, are 4 quadrants. Is north, south, and this will be west, east. There is upper part, which will be north. Okay. The amount to split by is going to be it needs to be rounded to a number of twice. Well, dividing in half, aren't we? I can just do divide by 2. Vote. I do that for both X and Y. Bit there, bit there. Now, this integer divided by 2 on an odd number will give you a smaller number. 5, you'll get 2, and the remainder will be 3, but we'll go with that. And what we're doing here is we're fully recursing into the filler, which is here. Keep that. I'll start with the same seed. We'll work that out in a minute. There's a few other things we'll probably need to do. Just get them in and see what happens. That decision that we're going to our quadrant decision. If we that get quadrants more than, I mean, we're not doing any of the subdivision anymore. We've only got the simpler fills and borders. We're getting quadrants. I'm not sure how useful this continual update is, but it's good. It gives you a view of things. We can see, let me go back to you can see that the quadrants are not symmetrical. What we need to do is reorient them, and also I was going to have the diagonal seeded differently, just to give us more variety. Do that. Use seed stream. So let's have the southwest, that one, and the northeast, which is that one. So they're now different. They recurse, and we need to reorient them all slightly. Basically, each one needs a different rotation. Yeah, wire them all up. Z0 in first. And let's leave the first one. Okay, that's one. Right then, they're symmetrical. They're symmetrical. One, two, yeah. So these two are mirrored and these two are mirrored. Nice results. Lots of interesting stuff happening now. think we need to have the split happen. So this needs to be some logic here to decide that we what the probability 50%. Okay. Oh yeah, I've got more variety going on. I think the low-level variety is lacking, but again, I think that's because we're not using the small pieces yet. That gives us a bit more level. Oh, we're going to look at the split mirroring. A good example of that. I mean, I guess that shows it. If we look at it from this direction, center section and then the two sides are not mirrored. They probably should be. Mirroring is tricky. Rotational is easy, but mirroring is trickier because that affects all of the logic all the way down. Might not be that easy to do. Rotational one might be enough. This has got a better example of the problem. Variety, quite a lot of borders. Don't want. Okay. That illustrates it. That's what you'd expect. Wouldn't align, match both of them. All right. Yeah, things like not making the same decision two in a row would help with variety. Yeah, this everything you add enriches the results for all the way through. Kind of you get a usable result quite quickly, and it's just a question of how much effort or resources or time money you want to put into digging deeper and deeper into producing richer and richer result. That richness. But unlike traditional assets, which are build it and then it's made and that's it, if you decide to go deeper on a meshes or something, then that's a whole lot of work to rebuild them. Whereas adding depth to procedural systems means you can dip in here and there, adding more logic, and your results improve across the board. That's one of the big strengths of it, I think. Sorry, I'm not talking properly into the microphone. Yep, we haven't really looked at parameterizing this particularly. So those things like the probabilities could be parameterized by some control to do with how certain decisions are made, and which would kind of, you can steer it towards different looks, I guess. You could do things like switching in optional extra meshes to use. We haven't done any skinning yet. Like there is a colored skin for these, colorizing skin, which might work mixed together, or it might just look messy. There are some nice ones in there. Some of them do still look repetitive, but I think we definitely need to look at the smaller. Wow. That one. Yeah, that's gone off on the same decisions all the way down to some degree. You can see that some of the logic was been used as the 3 split. There's 2 axes, I think. Yeah. Oh, and it's got to 4, and then it's decided just to fill it with the 4s. Yeah, I mean, it's a design. So yeah, I think that might be it for today. I'll probably do a bit more on this next time, and then we'll start looking at other things to do. I'd like to get doors in. There are some door pieces to have between sections, and maybe some control logic so we can. Oops. Some door logic so we can maybe add doors in when things intersect. I don't know, that might be a bit ambitious, but we can certainly have some parameterization to allow for doors. Let's see if we can find a nice. This sort of really looking quite cool. Small loop section here and a large loop section in the center. Works really well. Bit of asymmetry going on. Of storage bank thing going on. Yeah, that works really well. I think it might work. I mean, the largest, this is like artificially large and can start showing up some of the problems. Wow, it looks like a circuit board or a processor. The smaller ones tend to show off things better. Well, that's interesting. That's got, oh no, it's the lighting's different on the two sides. Yeah, that's got a nice split. Let's have a look through the example scene again and see what sort of feature designs appear and if there's any other type of splits or logic we can use. Probably a good idea. Yep, I think that will do for now. We've got more variety. Some of the ceiling ones needs fixing up, and there's still a bunch of assets we haven't used. I don't know if I will look at those next. Maybe I would do that off stream, add in some more variety, show you the results, and take you through it. And then we can focus on doors or walls or I don't know. But I'll have a look at the test scene as well to make it and decide what we're going to do next. Any suggestions? Of course, welcome. I think I'm going to call it a day. An hour and a half. That's a long stream. All right, thanks for coming. And thanks for the comments. I'll be back next week.